This is the first iteration of a DIY junk bin SMD vacuum pickup tool. It's basically one of those cheap $3, $2 pickup tools you buy on eBay. They don't work at all, by the way, but they do come with the tips, which is nice, and they come with the tube. So I just took an old aquarium pump, reversed the diaphragm, ripped it open, just put a brass T connector in there. Probably should use a plastic if you have them. They're a lot less weight, and just use that as the as your vent hole. And I just heat shrinked it and got some tips for it. Worked really good. I wound up actually running the tube just all the way through to the tip, and then I don't know if I glued it. I forget. But anyway, you can create a seal on that front tip, and you have something to hold. And I used this for a little while. It worked pretty good. It's really cheap. Total part cost is probably like $10, and it's got an old aquarium pump. Put a little piece of silicone on the end of this T connector to just help it seal when I'm touching it. So yeah, it worked real good. So the next step was to add a foot switch control to turn the motor on and off. I actually decided to use solenoids instead. I got these little several dollar miniature air solenoids. They're 3 ways. I used 2 of them, and I just bought the cheapest foot switch I could on eBay. It was like $3, I think. It's kind of one of those lamp switches, and I just stuck a phono cord in there, phono jack, and then used a existing headphone like cord to as the wiring. You could probably use a sewing machine foot switch, or you can kind of find some foot switches all over the place. There's a lot of cheap ones. Surprisingly, they were all fairly expensive for even the crappy ones. But you can get all kinds of different foot switches. They have tattoo machine foot switches and sewing machine foot switches. Then you can get industrial ones. I wound up eventually bought an industrial one. So I'm just making a little board here that contains the 2 solenoids and some breakouts. So I could just, on the fly, wire it. There's no logic. It's just going to go through the switch and turn on and off. One's going to turn on to vent, and one's going to turn on to break the suction. I've started to use this method of prototyping a lot. I actually bought a bunch of spring push connectors as well. They seem to work a little better for breadboarding than screw terminals, because you can actually put some of those breadboard wires go right in there if they're long enough. But I just throw a bunch of screw connectors on a proto board, and it just gives me the ability to soft wire everything together and use like a jumper kind of process. It's a little easier than wire wrapping and stuff like that. Having to solder everything, and you can't really change it after you're done prototyping, and you're kind of left with something that you can't use. At least I can take these apart and reuse them for a different project, and just reuse the way it's set up. Just change some of the wires, like a mini, wire to board kind of interface where you can just kind of jump things together and use it as a backplane for your project. So it was my intention to DIY a pickup tool just out of some nice like aluminum tubing and some hoses and maybe like syringe parts. But then I found a great deal on these genuine pickup tool pencils online on eBay, and I had to buy them. There's 3 of them and a whole bunch of different lure lock adapters. Now these are the ones with the hole for finger control, but you just cover them up and I can use vacuum control. I realized that I really need to have some kind of positive blowback for small parts, SOD 523s, anything smaller than 603 kind of sticks to your pencil. So you really need something to blow it off. We're not even talking about magnetism at this size. We're talking about just, pure static electricity and some other clingy forces that anything sticky on there or anything like that, you can't get the part off. So here I'm just testing out the ability to blow air with just one of these little aquarium pump things you can buy, DC motor pumps, and they're pretty strong. I was originally going to keep the solenoid count low and just have a blow motor that I turn on, but whether or not it's going to be fast enough, I wasn't really sure, but this would definitely help. These are fairly powerful when you're just pumping all this air through this little hose. So they're pretty neat. So I took apart some of these pumps. I was hoping I'd be able to reverse them, change the diaphragms to make them vacuum pumps, because these would be a great solution to have a little $4 DC variable vacuum pump. But the way these are made, you really can't do it. They're kind of molded and shaped just to pump air. And this is how it works, in case you were curious. Thought I'd take some video while I had it apart. This is a full test of microcontrol of the blowback and foot switch. Of course, you could do this analog or with like a 555 timer and just a variable pot and set your pulse time and stuff like that. But I thought it might as well have a microcontroller. Then I can modify how the pulse times work on the fly, and maybe reuse it as something else. I could switch blow on if I wanted to and use it as some kind of parts blower or dryer. And then I can use the foot control to trigger all kinds of actions based on how it's clicked. And then handling the sleep of the motor and the pump and all that stuff when you're not using it. Gives you a lot more flexibility. So I'm probably going to throw ESP8266 in here, give me Wi-Fi control of it. So I can change firmware and just change settings on the fly. But this could definitely be built with some jelly bean parts. So just to get your prototype a little more organized, throw it in a bin. Keep the wires all secure. Keep it from flopping around your bench. And this works great for, you can put a lid on this, and I used this for a couple days just to test everything out, make some changes. So I decided to just buy a larger aquarium pump that can put out a bit of air. There's even a bigger one than this. This is like a $12, $13 Walmart. This actually has 2 chambers, so I could set one up to vacuum, one up to blow. To modify it, you just have to rotate one of the diaphragms 180 degrees. You will have to punch a little hole in the rubber diaphragm just to get it to go over the alignment pin. Might as well upgrade my foot pedal somebody made a video about this foot pedal. Never saw it before. I don't know why it didn't come up in my searches, but it was fairly cheap, so I bought it. Started in Fusion 360, started modeling up the entire tube assembly and all the parts and how they were going to fit together. And I figured I'll just put the entire thing in a tube, just to keep running as a prototype for long term, and as like kind of like a platform for other different projects. When I'm done with this, and if I build this out to a PCB or something like that, it'll be a lot smaller. And I can continue to use this kind of enclosure for throwing quick prototypes into a safe enclosure. Something that you can carry, move around safely, and it's no danger of having it damaged. Even if you had a breadboard, it would fit in here. So a lot of this was just kind of iterative and freestyled. I wasn't really designing this from scratch. I just kept, I needed a piece to hold the electronics, so I printed that part, tested it out a bit. And then I needed like these rings to center it in the tube if I was gonna. And then I decided to how I was gonna mount the pump down in there, and if I wanted the hoses all to be straight. Most of the length of this is because I wanted the hoses to not have any right angles, just to maximize the airflow. A right angle drops pressure a lot. And then, of course, a lot of this was learning how do I model hoses and stuff like that. It's a little difficult when you're doing 3D sketching, not 2D sketching. You have to do 3D sketching for hoses and stuff like that. It's a different process. You need to play with a lot before you get the hang of it. But most of this was just so I can design a system that was modular and then used heat inserts to bolt it all together. I have knurled inserts all along here, only on the bottom, but this can mount like this. For example, alright, so then I can stand it up while I'm working on it and just hold it where I want it in the tube. And I can also use this to hold constrained components and wiring. So the basic idea is that you can build a skeleton down the tube, interconnecting rings. Use like a standard, kind of not a standardized. I kind of just put this together just randomly, but it's some good ideas I need to modify a little bit. So then I printed these larger ones that can be used as compartments, separate, sections or whatever. But it didn't finish printing. I printed two of them. They both broke. The nozzle was slamming into something and knocking them off. Exactly the same failure. So now I'm trying to come up with a way to run a rail along the whole thing that I can screw these onto like a rail, and then I can use that as the scaffolding. I was going to have a rail anyway that these would screw in. I'm just going to have to run it through and just screw into that, just so I can use these. I mean, they're really nice, well printed. Just these tabs stopped at this layer. So this is kind of what I was thinking. See, this was supposed to go where that one is. This was supposed to go on here like that. And then I have this shelf that I can put the AC and stuff for the motor. This wiring, and then the hose, the hoses, all that shit. But that didn't work, so kind of this is what I'm going to do. I'm going to put it like this. And then this motor's got like a curve on the back, but I should be able to fit it in there. See, now these rubber feet are pushing on that, so that's vibration dampening. Now I just got to handle some kind of vibration dampening on the top. Seems to be warping a little because of that plug. I can take that strain relief out. I won't need it. So that's that. That's all contained in one. And then I have this section on the top to, use for, I could put like an AC outlet in here if I wanted to not splice wires or something. And then, this section would be safe. You would just put the pump in and plug it in. So this is going to go on the back like this. And all the pneumatics is going to go here. All the pneumatics will be here, and I'll build something to hold all the hoses together so they don't vibrate and move, and the solenoids will all mount in here. And then I'll run the wires somehow through over here. So right now I'm making a rod that's going to go through here and mount all of this together. So it'll be one big piece. That's that. And then I thought it'd be nice to have a ring that could go in the middle of this so that I have support, somewhere in between. And I have holes here, so, but these won't fit because of the way this is made. This was made a little wider, so I made this. Alright, so these are these rings that go on the ends, but I thought, well, maybe I can make something that slips over and still has enough room to fit in the tube. So let's test it and see. Oh, it's so close. Yeah, it should be okay. So it should be okay. In fact, that might be cool if I can design a spring into here where it actually can compression fit along the entire length. That would be cool. I was wondering how I was going to do that, and that might solve itself. I'll have to make it a little bit different, but anyway, so how this works is I guess I'll need some screws. I don't think I have any more of these. Yeah, there's one right there. Alright, so let's see if this works. So this goes on like that, and it should slot right on there. It's a little tight. It's hitting the PCB right here. Let me get it past there. Alright, well that was an idea. I'm probably better off just tapping in here and putting a ring. But I could just cut this right here, but that seemed to work. Maybe if I could just take that, I gotta take that, see that I put that little, my thinking was that I'd run all the wires through, hook them in there. So they wouldn't get lost. You know, everything would be organized. All the wires would go through there. And I'd have little hooks to put wires in, but there's really not that much space. There'll be plenty of space if this is all on a PCB, but this mess is just not enough room. And this is just to hold this so it doesn't break the wires while I was flopping this around. This is going to go up in the top section.